Welcome to this short film by the TOPNES collaboration. We are a group of scientists working at universities around the world who are trying to understand the behaviour of new types of materials. Our world is governed by materials, and solid materials have a wide variety of properties. Metals conduct electricity easily, while insulators don't. Semiconductors are in between and are crucial for modern technologies. Some, like iron, are naturally magnetic, but others are not at all. So, what makes this variety possible? The different behaviour of electrons in solids. In this video, we'll discuss a very peculiar property of electrons in materials, topology. The T in TOPNES stands for topological, but what does that word mean? Let's start with a simple example. We take this strip of paper and make it into a loop. This loop has two sides, an inside and an outside. We can draw a black line on the outside and a red line on the inside, and these lines never meet. Now let's make another loop, but this time we're going to twist the strip of paper first. Let's try drawing a black line on the outside of this. The black line covers all of the paper. There is no inside and outside here. This loop has only one side. This kind of loop is called a Möbius strip. Now for the really weird bit. If we cut the ordinary loop along the line we've drawn, it falls apart into two separate loops. But if we do the same to the Möbius strip, it makes one larger continuous loop. There is no magic here. You can do it yourself. Imagine you were an ant, living on the surface of one of these strips of paper, and only able to see the part that was near or local to you. How could you tell whether you were on an ordinary strip or a Möbius one? The answer is that you couldn't, unless you walked all the way round, drawing a line as you went. Here, the ant has come back to the start of the line, but the line is now on the other side of the paper, meaning that the ant must be on a Möbius strip. What's the moral of this story? It's that the two types of strip are different, even though there is no local way to tell them apart. Things that are different in this way are called topologically distinct. Things can be topologically distinct because of twists, because of holes, and in many other ways too. Here at TOPNES, we look at topology deep in the interior of crystals. In the end, this could help us to discover new varieties of solid, or to make new types of computer. Scientists, in fact, use many types of complex machines like these to look at building blocks at the scale of single atoms and electrons. The aim of our research is to study the atoms and electrons in materials to understand why they have the properties they do, so that one day we can make a material with any property we would like to have. Imagine making a material which you can write on and tastes as good as chocolate. There would be much less waste paper. If we've got you interested and you'd like to know more, here's what to do. Do you already know a bit about physics? Then check out these videos, which have been made with you in mind. Looking for a simpler introduction to what we do? Then take a look here. For details of our research and public engagement activities, here's a link to the TOPNES website. Thanks for watching.